All right, welcome back, everybody. We were doing conversions, where we had our conversion bridges. Let's maybe do some more. Chapter 4. This is on conversions. And so let's say we want to know how many seconds are in 1 year. Alternatively, you could do something fun like how many hours have passed since the moment I was born. That would require exactly knowing what hour you were born at, but this is a doable thing. So we want to do our little conversion thing. We want to start with 1 year, because that's what we're working with. And we want to end with seconds, and we don't know how many it's going to be. But I do know, and hopefully you guys don't need the sheet for this, since time is something you deal with frequently. There are 12 months in a year, and I want to get rid of years, so I'll throw years overboard. I'll put months on top. And we could do 12. Wait a second. That's not really a good idea because the months have different days, right? Different amount of days. So maybe let's cancel that. Sometimes we got to stop and think about what we're doing and go, okay, that's not really a good method. So I go 12, what am I going to do to get rid of months? Some months have 30 days, some months have 31 days. This month has 28. So maybe we should look at like 1 year has days, 365 days. We're going to ignore the leap year component. Well, now I got something I can work with. Because I know a day has 24 hours. So I can dump days by throwing them over the bridge, pick up hours, and just make sure I put in the right conversion between them. 1 day has 24 hours. Then my days cross off, and I have hours, and we're getting there. Some people know how many seconds are in an hour, but if you don't, you know how many minutes are in an hour. So let's get rid of hours and switch to minutes. 1 hour has 60 minutes. And finally, we're almost there. We're almost there. Minutes turn to seconds. At the same rate, 1 minute is 60 seconds. And we can see that we've managed to cross off years, days, hours, and minutes, and now we're just down to seconds. So our units are in seconds. So these bridges act like multiplication. So I'm going to take the 1 outside, multiply it by 365 over 1, 24 over 1, 60 over 1, and 60 over 1. And when we do that, we should be in seconds. Let's figure out what that is. So I've got 1 times 365. I fat fingered the keyboard. 365 times 24 times 60 times another 60. And I am getting 31,500, not 31,536,000 seconds. Okay. time breaks down even further, just so you're aware of it. They will often do 1 millisecond. 1 ms is 1 millisecond. This is like stopwatch stuff. It's 1/1000th of a second. And the other big one you see is nanosecond. And that has 9 zeros. 1/1 billionth of a second. So at this point, only computers, something that moves at the speed of lightning, can do something like this, because we can't. It doesn't matter how quickly your hands are, you're not capturing 1 nanosecond. You're not capturing 1 millisecond. We did the gallons to teaspoons. That was fun. So where does this come up in life? Recipes. Wait, does anyone need that up longer?
Like when do we use it?
No, any of these conversion things. There's lots of times they show up. One is like finding out how many seconds or how much time has passed. Another is converting like we do. Let's do it. I am 5 foot 5.5 inches. That's Hefe's height. How tall is he in the metric system? When we go internationally, then everything is shifted to the SI units. Cars have miles per hour, and it also shows kilometers per hour. When we work with other countries and we need to have stuff between it, we need to do the conversions between them. So this is one of those, I don't know those things because I'm not some conversion freak. So I'm going to come over and look at our table and go, what do I have that I can convert feet to inches or feet to centimeters? That tends to be your feet to meters. And I see right here, I'm going to write it down so I don't lose it. I've got 1 meter equals 39.37 inches. So I'm pulling that from the top one. So maybe I should get my height in inches first. So I'm going to start, I'll convert my 5 feet to inches. 5 feet. 1 foot is 12 inches. And I get to cross off the feet, and I get 5 times 12 inches, which is 60 inches. And that was just my feet part. Now I'm going to add the 5.5 inches. I'm really, the 0.5 is important to me because I'm shorter than most guys. And so like that extra ½ inch matters. So I am 65.5 inches tall. When I say it in inches, I sound taller. I feel bigger. I feel greater. So now we can convert this to meters. If I start with inches, and I use that conversion we had up above, and I want to throw inches overboard and pick up meters. And it says 39.37 inches is 1 meter. And I think that's gonna make me feel really, really short, so I'm gonna go to centimeters. I'm gonna switch to centimeters. I think that's how a lot of them report height in the other countries anyways. Because otherwise you got a lot of decimal places to represent someone's height. But if I switch to centimeters, 1 meter is comprised of 100 centimeters. And we can cross off our meters now. And now all we're left with is centimeters, and I just need to calculate how many. So what I have, if I get rid of all the bridges and just use parentheses, I have 65.5 times 1/39.37 times 100/1 centimeters. Oh, I did times. Really? Really? 166.37 centimeters. And I'm going to round this to 166. And not have the 0.0, just dump the zeros. 166. The reason why, and we're going to explain this more in the latter half of the day, is when you're taking measurements, if you have a measurement, you don't want any more digits in it in the answer than you had to start with. This is called significant digits. And there's a little bit more to it than that. When we get to that, I'll explain it. Significant digits, or they sometimes say figures. And so some people will abbreviate it to sig figs. But I started out with 65.5. So I only have 3 numbers there. I'm going to end with 3 numbers at the end. That's the idea. Any questions?
How did you get the 166?
Did you use? Okay, so when I put these together, I have 65.5 divided by 39.37 times 100. Make sure I have that. Because numbers on the bottom you divide by, and numbers on the top you multiply by. You want to try again? Like hopefully you guys get the 166.37. Let me hit clear and do it again. Yeah, I'm still getting it. So the numbers on bottom, we divide by, the numbers on top, we multiply together. And since it's all multiplication and division, we can just go left to right. You can do multiply, divide, multiply, divide, multiply, divide. As long as you keep going that way and don't use any parentheses on the calculator will know what to do. Do you have it this time? I see you might have just typed something wrong.
I changed the 39, 37 and put it on top.
I started to do that too. Yeah, if you put them on the wrong side, it's gonna make a difference. Okay, so sometimes we don't want to just do conversions. We want to break things down into smaller parts. Like, let's say you work for, I don't know, fucking donut shop or Starbucks. I've never worked at Starbucks, so I don't know how much fluid they have. But let's say you got, it's like Monday morning, Saturdays and Sundays, you're busy. Let's say it's a coffee shop or some shit like that, a donut shop. They're busy on Saturdays, Sundays. They have large recipes for them, but Monday's hella slow. Or Tuesday's slow. And let's say the recipe, a recipe requires 11 gallons, 3 quarts, and 1 pint. And you only want to make 1/3 of the recipe. So we want to basically divide the recipe by 1/3, or divide the recipe by 3. Since we have all these switches and conversions between like gallons to quarts and stuff like that, it's not just something I can plug in the calculator and just go. So I need to like work out what I'm doing and take it slowly. So I'm going to write old school, an old school setup. And the division part goes as normal. It's when we're shifting between columns that we got to be careful. So I can divide 3 into 11, and it's going to go 3 times. So I'll put 3 gallons there. And then 3 times 3 is 9. So I've used up 9 gallons, and I still have 2 gallons left. One gallon is 4 quarts. So if I double this, I get 2 gallons equals 8 quarts. So that's what I'm going to do. I'm going to take this 2 gallons and then I move it over into the quarts column, and I'm going to put it as quarts. And then I can add this up and see how many quarts I have right now. Then we'll do the division again like we did above. The 3 goes into the 11 3 times, so I'll have a 3 with quarts. And I'll do the multiplication, minus 9, and I have 2 quarts left. And I want to do that same type of conversion to pints. So 1 quart is, I believe, 2 pints. But let's check. check our table. One quart equals 2 pints. It's on there. Which means if I double everything, I have 2 quarts equals 4 pints. So that's what I'll put here. I'm gonna bring that 1 pint down and I'm gonna add it. I'm gonna have 5 pints. Finally, we divide the 3 into the 5, it goes in 1 time. So 1 times 3 is 3. I subtract 3 pints. And I have 2 pints left. What I'm going to do with this too is, since the lowest unit I had was pints, I'm going to leave it as pints. I'm going to take this 2 and I make it the top of a fraction right here. And we'll do the same thing with the 3 out here. We'll make this the denominator. We'll say we have 1 2/3 pints. So a recipe that takes 11 gallons, 3 quarts, and 1 pint. If you only want to do 1/3 of the recipe, that's how much you need of like milk or whatever the ingredient is. It's kind of complicated, huh? Something that takes practice. Thankfully, there's practice on homework. You all like doing homework, right? I don't see anyone nodding. I'm getting even dirty looks. What's the dirty look for? You're like, give me dirty looks. All right. What else do we have in this section? Well, now you're smiling suspiciously. Both of you. What the fuck are you two up to? Up to no good. All right. So other stuff we have in this section. Working in SI, working in the SI system, the international system. They don't like listing things with like a lot of decimal places. So when I said my 1 year was 31,500 or 1,536,000 seconds. We calculated that. What they do is they go, okay, how can I write this with just one number in front of the decimal place? They're going to say, I want to say 3.1536. And then they're going to make it multiplied by 10 to some power up here. And the way they figure out the power is they count the number of places that are after that where we put the decimal. There's 1, 2, 3, 4, 5, 6, 7. So they will say this is 1.536 times 10 to the 7th seconds. Calculators will spit this answer out a lot. If your number is too big or too small, it will spit out answers. This is called scientific notation. And it will spit out answers in scientific notation. So calculators use this a lot. Give this as a result. If you have that up here and you want to go like, what the hell is that? The key to it is, like if I've got 1.234 times 10 to the 11th power. What I want to do is I'm going to write my 1, 2, 3, 4, and I'm going to start moving this over and counting how many times I move it. And once I start running out of digits, I start adding in zeros. So I'm going to add in a bunch of zeros. I don't know how many I need, but since I made my number big, I'm going to add a bunch in. So here I've gone 1, 2, 3, 4, 5, 6 spots, 7, 8, 9 spots, 10, 11. My decimal goes right there, and I don't need the rest of that. Now, if I want to write that like a normal person, because that's unreadable to me still, because I don't have any commas, I will start putting commas in, starting at the right and working left, go every 3. So this ends up being 123,400,000,000 of whatever it was. If it's got a negative exponent, like 5.6789 times 10 to the negative 7. Up here, we moved right the exponent value. When it's negative, we're going to move the decimal point left that many times. So I'm going to have a 5, 6, 7, 8, 9. And I think the easier way to do it, rather than trying to write a bunch of zeros and going from there, I moved over once right now. I need to move over 6 more times. So if I need to move over 6 more times, I need to add 6 more zeros. And put my decimal point. And then to probably make it readable, I'll put a 0 there. Just to make sure that people know it's a number and that is not a period in a sentence. And that's why they use this notation. This part is at least readable. I can at least read this as 123,400,000,000. At this, I'm like, I don't even know what to call this. Like, it's going to be awkward saying it in words, so they just shift the decimal over until it goes where there's only one place. And if it was a decimal, it becomes a negative value. And if it's a positive, if it was a big number, it becomes a positive exponent. That's scientific notation. That's how calculators do it. Or show big or small results. We'll look at that some more in a little bit. But it all boils down to shifting the decimal point. Any questions so far? Okay. But
I'm still like trying to process. Gallons and
There's a lot of units in it, and I'm not going to expect you to memorize them. You will have access to these charts, so you can see what the numbers are. The way to go about doing it is, and we'll do it, like, let's do another one with converting between the US system and the metric system. Like, what's the speed limit on 99? 70, 75, 70. Let's take a look at what the speed limit is on 99 in metric system. It's 70 miles per hour, and we're going to change it to, we want to end up with kilometers per hour. And we'll have some unknown value here. Now, NPH is miles per hour. When we're doing our conversion bridge, this is really 70 miles over 1 hour. That's my starting day. That's what miles per hour means. That's 70 mph. And I want to get rid of miles. And I don't know how many miles are in a kilometer, or vice versa. This says 1 kilometer is 0.6214 miles. This is going to be a fun one. Let me look this up real quick. .6214. Let me write that a little bit bigger. 1 kilometer is 0.6214 miles. And you have your chart out in front of you. You can find it there too. I found it right here. Okay. So if I do that, the miles go away and I have kilometers over hours, which is kmph. Which means all I've got to do is, this is 70 over 1 times 1 over 0.6214. And numbers on the bottom become division. So this is just 70 divided by 0.6214. Why didn't that work? $70 divided by, and I am getting that 70 miles per hour equals 112.64. I'm going to write them all down. And I'll probably just round to 2 decimal places. This wasn't a scientific measurement, so I don't need to chop off significant digits. This is kilometers per hour. Okay, so here's a fun one. Escape velocity. How fast does something have to go to escape Earth's gravity? Like, go to fucking outer space, like that kind of cool. That's pretty cool. Now, it's related to the distance from the Earth. Like the farther up you go, the Earth's pull on you is a little bit less. The closer you are to Earth, the stronger the pull of the Earth is. But they know the escape velocity on the surface of the Earth. On the surface of the Earth, it is 11.2 kilometers per second. Make it kind of relative to you. A rifle bullet. I'm looking, this is straight up. I typed in escape a lot, but fuck it. So on the surface of the Earth, the escape velocity is 11.2 kilometers per second, which is Mach 33. A rifle bullet is 1.7 kilometers per second. You know how fast a bullet goes. 11.2 is like, I don't know, 8 times larger than that, 9 times larger than that. Let's figure out how many like miles per hour that is. So this will be a fun, like, practice thing for conversions. We're going to start with the 11.2 kilometers per second. And that's per 1 second. I eventually need to end up with miles on top and hours on bottom if I want to go to miles per hour. So I'm going to use that as like, where am I going to figure out what the hell I need to do? It looks like I need to switch. I need to get kilometers to go to miles. And I need to get seconds to go to hours. So we're going to have to focus on switching both. But we'll do them one at a time. So let's deal with the kilometers to miles, because we have that value right up top. 1 kilometer is 0.6214 miles. I'm going to put MI. You're like, yeah, where will I use this in the trade skills? Nursing, construction. You won't. This is just cool shit. And it's good practice for conversions. All right, now I'm down to miles per second. Do you guys see that? We got miles left on top here. We got seconds left on bottom here. We don't want to look at miles per second. We want to do miles per hour. So I want to get rid of seconds. I don't want to put it on the bottom. I want to be able to cancel it out, and it's on bottom already. So what I'm going to do is I'm going to put seconds on top. And seconds convert to hours. If I put seconds on top, I've got 1 on bottom and 1 on top, and they will cancel out. And I just need to make sure I put the right conversion in. 1 hour is 60 seconds. Or 1 minute. 1 minute. What am I doing? Hours. My bad. If I want to go to hours, I need to dump minutes and pick up hours. I was getting a little hasty there. And I know there's 60 minutes in 1 hour. So I can cross off minutes now. And the units I'm left with are miles per hour, miles on top, hour on bottom, and that's what I want. All right, so what is the math here? Every denominator is just 1. So all I need to do is multiply these together. And we can figure out the escape speed in miles per hour, something we're familiar with. $25,054.85. About 25,000 miles per hour. That's crazy fast. That's fucking fast. All right, let's talk about those significant digits. Let's do the significant digits a little bit more. Does anyone else need this longer? Let me know. Okay, ready? Significant digits. This becomes a huge issue in chemistry and stuff like that, and the sciences. And the idea here is our answers can only be as accurate as our measurements. And the way they decide this is they can count the significant digits. And so we need to address what counts as a significant digit.
So when you do a measurement, what's best, to round up or down?
Usually round to the appropriate rounding, like up if it's above half and down if it's below half. But there might be circumstances where, like,
But it's a whole.
well, it's again, it's specific to the thing. Like if I'm trying to fit something into a hole and I'm measuring the width and I round up, I'm going to make something that's too big to get into the hole.
Mhm.
Does that make sense?
Yeah.
So if it's like 15/16 of an inch wide and I round up to an inch wide, screw isn't going to go into a 15/16 inch hole. So like, that sounds weird, but usually when we're rounding, if the next number is 5 or larger, 5, 6, 7, 8, or 9, round up. And if it's 0, 1, 2, 3, or 4, we'll round down. So rules with significant digits. Okay, so whole number, any normal number like this, it's all the non-zero numbers. It's all the numbers like this. So this one has 4 significant digits. If there's numbers that are not zero at the beginning and the end, like if I had 2002, the zeros in the middle also count. This is 4 significant digits. If I only have 2100 like this, and then there's no decimal point, trailing zeros don't count unless these are called trailing zeros. Don't count unless it's clear they are not rounded. $2,100 as it is not clear, so this only has 1, 2, 2 significant digits. If you put the decimal there, the decimal is used to indicate I actually measured this. This is 2100 exactly. And we would say 4 significant digits, because the decimal indicates that it was an exact measurement. So all the numbers that are actually non-zero always count. Zeros between non-zero numbers count. Zeros at the end don't count when they're in the whole number unless there's a decimal. And then let's look at like decimal place values.
What are we measuring?
What?
What are we measuring? What are we measuring?
Like if we pulled out a tape measure, or we had a scale that measured like 4.65 ounces or something like that.
Mhm.
Something that you're either weighing or measuring, or like time we measure with a stopwatch. It's something where we find a start value and a stop value, and we're finding the distance along. Weight is, it's kind of weird thinking weight and time as distance, but you're finding a difference in bound values. On a scale, it has a starting weight of 0, and then you added something to it, it's got an ending weight of something else. So, if we have this zeros in front are considered not significant. If everything in front of it is a 0. And that includes the whole number part. I'll show an example like it within a second that has something different from the number. So that one does not count. These 4 count. Four significant digits. So, like if you're doing something like if you take a chemistry class or something like that, the only time you put a 0 at the end and then like a decimal place thing is if like the scale or whatever you're working on measured it. Anyway, if we rounded to the 0, if we had like 7649 and we rounded to 7650, we wouldn't actually write the 0 there. So showing the 0 there means we didn't round to get it. So that's why we include it. So if you rounded it, it would have just had a 0.0765. Now, if you've got numbers that are in front of it that are not 0, like if we had 100.013, even though I said the numbers in front of the decimal don't count, there's a 1 in the very front. So everything between whole numbers counts. So there's 3 here, there's 3 here. That leads to 6 significant digits. That's how significant digits work. If you have to do conversions, you use the number with the smallest amount of significant digits. If it's clear there was rounding. So like if we look at the table, like 1 foot to 12 inches. We know these are exact, so we don't worry about their sig figs. Don't count these. But if I'm switching 60.4578912 miles to kilometers. And this was, what was this, 0.6214? This has 259, this has 9 sig figs. This has 4 sig figs. So in my answer, whatever I get here, I only want 4 sig figs. Because this value was rounded when it was done. When you measure 1 kilometer, it is not exactly 0.6214 miles. They just stopped writing decimal places. precision. This is called accuracy here. He's counting the significant figures.
So you just get rid of. You just use 4 and the rest you can.
Yes. Let's finish that. I think the answer will be better for you. Excellent point. So 60.4578912 divided by 0.6214.
So we get rid of
I'm getting,
after.
what I get from the calculator is this. I'm only gonna count the first 4. 97.29 kilometers. So anything extra, I'm gonna chop off because I'm basing it on this number right here. That's telling me how many significant figures to use.
I was thinking to get rid of the last 4 as well.
No, it's how many you keep. I'm glad you asked. How are they describing precision in her book? I'll get back to you on precision. We'll do that on Monday. Let's take a look at the last topic, not even the last topic in this section. Let's look at another one that we've not dealt with is temperature. The temperature between the two systems. In the US, we use Fahrenheit. And in the SI system, they use Celsius. So for some information for you, the freezing point of water and the boiling point. We'll look at freezing point and boiling point. What temperatures these occur at? In Celsius, it's 0 degrees Celsius and 100 degrees Celsius. Nice and simple scale, 0 to 100. And then we have the American way. The American way is 32 degrees Fahrenheit and 212 degrees Fahrenheit. Like numbers you actually have to remember. 0 to 100 is easy to remember. Then Americans come along and said, fuck you, science, we're going to do it our way. So, this actually, I won't teach you how to generate it, but these two things are the basis for where they come up with the formulas for Fahrenheit to Celsius. So if we want to start with Fahrenheit and go to Celsius, the amount in Celsius is 5/9 times our degrees Fahrenheit minus 32. (98.6 degrees Fahrenheit, that's the average body temperature, right? 98.6 degrees Fahrenheit is the average body temperature. let's see what it is in Celsius. In Celsius, it's 5/9 times 98.6 minus 32. So I'm going to do 98.6 minus 32 first. And I get this is 5/9 times 66.6. In the calculator, I can do 5 divided by 9 times 66.6. .37 degrees Celsius. So that's the Fahrenheit to Celsius formula. And if you want to go the other way, start at Celsius and end in Fahrenheit. Like, let's say this comes up a lot if you're traveling internationally and you're like going like, oh, we're going to fucking Australia. And Australia's going to tell us the daily weather temperatures are in this degree Celsius. And you're like, do I need to fucking pack shorts or a sweater? I don't know. Like, talking to me in Celsius means jack shit. Now, in today's world, you just plug this shit in Google, right? But this is where it comes from. It is 9/5 Fahrenheit is 9/5 Celsius plus 32. So if they say if it's 32 degrees Celsius, in my head, that's fucking cold because 32 degrees Fahrenheit is when water freezes. So in my head, that's cold. And so I'd be like, I'm packing fucking pants, sweaters, maybe a fucking scarf. I don't use scarves, but I might want a scarf if it's fucking ice cold out. But if I plug it in, what happens? I am literally going to do 9 divided by 5 times 32 plus 32 here. .6 degrees Fahrenheit. It's 90 degrees out. In Fahrenheit. When they say it's 32 degrees Celsius, it's not a super hot day, but it's warm outside. It's definitely not like sweater and fucking scarf weather and mittens and shit like that. Right? Okay, other things that show up in this category. Wait, I see things still moving. You're still writing, wait. All right, other stuff in this chapter is we've got absolute error versus relative error. So what we're going to do is we take the observed value or the measured value and we subtract the true value. And then they put these in something that's called the absolute value bars. And what it does is once all the calculations inside are done, make the value positive. So let's say you have a temperature of 102. I don't know if this is a good example of absolute error. It does the absolute value. So you have a temperature of 102 degrees Fahrenheit. Or let's say, let's lowball. Let's go 94.4 degrees Fahrenheit. What you do is what it should be is 98.6 for both. So let's say you have the fever. You're going to do 102 degrees minus 98.6 degrees. And when you subtract that, you're going to get 3.4 degrees on the inside. This is already positive, so I can just dump the absolute value sign. And this is a 3.4 degrees absolute. I don't know if I want to say error, but we'll say absolute difference right now. And we'll go the other way. We'll do the 94.4, like you're cold. We're going to do 94.4 degrees minus the 98.6. And we're in those absolute value bars. And I'm getting negative 4.2 degrees. And the absolute value bar is going to make this positive. This has got a lot of little stuff in it here. Relative error. Relative almost always generates a percentage when you're talking about it in terms of math and science. It's always going to have it's like percentage error. What we do is we take the absolute error and we divide by the true value. So for the 102 degrees Fahrenheit, my absolute value or difference was 3.4 degrees. I'm going to take the 3.4 degrees Fahrenheit and divide by the true value of 98.6. And since the things that were measured were 3 decimal places, I will use 3 significant digits, which are these 3. I will round, I'll look at that one and I'll round and I'll say 0.0345. And we just got doing percentages. How did we go from that to a percentage?
So there is, that's what we're gonna count the 0.
Yeah, you don't count the zeros in front. Remember, when we do the significant digits, we gotta only count significant digits. These 3 are significant, this first one is not. Zeros in front are not significant. And to go to a decimal or a percentage, we move the decimal right 2 times. This is 3.45% error. That's how relative error works and absolute error works. There might be something on it on the homework, but I'm not going to have it on the test. I'll just let you know that right now. One more topic in this section. You guys ready? Not everyone is. This is right. I'm actually going to wrap it up early today. We'll stop after I'm done with this. We won't start the next chapter. I think you guys are getting a lot of homework due in a short amount of time. And I want to give you a little time to catch up. I think my syllabus schedule is a little unreal. I thought I would be able to do better. We're going to slow it down some. And I will be editing the homework schedule and that syllabus as well. The last thing we talk about is distance and midpoint. So let's say you've got a ruler. This is my ruler. And I've got something here and it's at the 1.25 inches mark. And over here I have something at the 6.5 inches mark. So maybe it's a candy bar or something like that. How long is this candy bar? Generally, they're going to teach you is take the big number minus the small number. 6.5 inches minus 1.25 inches. And I think it's 5.25. That equals 5.25 inches. A better way to do distance. Subtract in either order. And take the absolute value of it, the answer. (6.5 inches minus 1.25 inches. If I take the absolute value, I've got the absolute value of 5.25 inches. And that's still just 5.25 inches. I can do it in the other order though. I can subtract the 6.5 from the 1.25. And this is going to give me negative 5.25 inches. And the absolute value sign just makes it positive. Just any negative sign after you've done the calculations becomes positive. So you're just subtracting and making the answer positive. That's pretty easy. Midpoint isn't too bad either. To find the midpoint, you add the 2 and divide by 2. Add them up and divide by 2. So on my ruler, like I can draw, like I can put that mark is. I don't know what that value is though, because I didn't measure it. So how do I find that midpoint right here on my value right there? What I'm going to do is I'm going to add up the 1.25 inches and the 6.5 inches. And when I have that, I'm going to divide by 2. I recommend you do it in 2 steps. Do the 1.25 plus 6.5 equals on a calculator, and then whatever you get, the answer divided by 2 equals. So if I do that here, I have 7.75 ends up being the top. $3.875. So the midpoint on this ruler between the 1.25 and the 6.5 is 3.875 inch mark. If your calculator has a parentheses key, you can do it all at once, but you got to use the parentheses key. Parentheses 1.25 plus 6.5 end parentheses divided by 2 equals. So the top one you can't fuck up. The bottom one, if you forget to put in the parentheses and stuff, you will get the wrong answer. Because it will only divide one of the numbers by 2. Are there any questions? All right. Let's call it a wrap for the day. You guys have had a lot of work. I want to give you a little bit like less on the plate. We'll start chapter 5. I'm going to adjust the homework schedule when I get home tonight. Just as a note. If you do feel sick. Or you've got the sniffles, you don't have to come to class, you can log in on Zoom. I'm airing this live right now, so
It's not being.
if you're still sick on Monday. You can stay home. Other than that, I will see you guys on Monday. I am not in town this weekend. I will answer emails in the evenings, but I'm at my mom's house packing it up.
Thank you.
Uh-huh.